I got this idea of developing this bed from what I have learned from my days at Stoke Mandeville Spinal Unit, where Dennis Newton used to be one of my senior colleagues who had this unique way of reducing the neck dislocations, but he was using hanging weights to try and reduce this fracture dislocations. And I always found that could have been done better. Lots of different methods and methodologies have been available in the past. If you look at the history, how it has evolved is, as a registrar, I remember that you would go into this kind of procedure, which was just a flimsy little rod, and you kept on adding 2 kgs of weight overnight. And as a registrar, that was your duty. Reduction rates were horrible, and you never got anywhere with it. So then came Dennis Newton's principles of rapid sequence increasing weight reduction, and this is where my procedure and technique is based on, where you add 5 kgs increments and you keep getting C-arm control x-rays. Dennis Newton has reduced these fracture dislocations arising from rugby injuries. Patients who had complete neurology, that means they had no arms or leg movement, were reduced within the first 4 hours. They have gone home walking within the 6 months period because they were reduced within the first 4 hours. And this device facilitates that reduction within the first 4 hours, simply because it is a very simple procedure. So when I came here, there wasn't a device, so I went up to medical physics department. Johan was the mechanical brains behind it. We sat together, and we kept on playing with ideas, and we came up with this device, which is first prototype, where we were still using weights, but we were using a gearbox in order to flex the neck, that is, advance the mast vertically. The bed is an important component of this device, as you can see, because counter traction and keeping the patient strapped is the key to getting this sorted out sooner. The weights have their own issues because they're dangling, they come in the way, there's increased chances of pin cutout, and it's not the best possible way to do this. So we came up with this methodology wherein we devised a rack and pinion model with a gearbox and basically a load cell with gearbox on the top, and this is the finished product. With this finished product, this is the first prototype. This type of product is not available anywhere. What we have done is we have done about 26 reductions through this particular bed, and we have managed to achieve 23 out of 26 successful reductions, which is a very good rate. And our series as well, what we have looked into, the ones who were reduced within the first 4 hours have shown the maximum neurological gains as well. It is easier system for staff to use simply because we have no longer hanging weights. The hanging weights were a problem being getting knocked, falling onto somebody's feet. Chances of pin cutouts were much higher with the hanging weights. And the main reason for that is the drag which you have on the pins on your skull continues to happen because the weights are still on there. Whereas with this device, what happens is as soon as the pin disengages from the skull, the torque goes down to 0. So if at all there is a pin, if there is a scalp cut or laceration, it is just a centimeter or so. Whereas with the weights, I have seen the lacerations taking away the whole scalp. You lower the bed first. Patient goes on top of the bed. The shoulders need to go onto the edge of that mattress. It's important that you strap the patient with the straps. You get the Gardner wells in position, and you torque the device to about 2.5 kilograms to begin with. You then raise the bed up. You then lower the leg end of the bed. This provides counter traction as well as add some weight. You get the C-arm or image intensifier placed in there, and you start the reduction process. So you keep going up till you have achieved another 5 kg, so that's 10 kgs. Then the mass still goes up, that's 15 kgs. And you looking at it after every 5 kgs in the image intensifier picture, that gives you whether this has reduced or not. And once it is reduced, you confirm that, you get the alignment back to neutral. And let's say this is a C5-6 fracture dislocation, you would put a maintenance traction of about 5 kgs. And once you achieve that, you just extend the neck a bit, simply to keep the fracture dislocation reduced. Now, we sat down again because we thought we can do this a bit better, because flexion achieved was not that great in the previous one. So we've got on to this curved mast or the curved gantry, which allows us to get neck flexion a bit more, which means that the weights which will be required is much less. So this is the one which we are marketing at the moment. We are looking at getting a multi-center trial starting here in New Zealand by getting 2 centers to do these devices, to take these devices up. Thanks to CDHB, we have got the funding to do so, and this means the interest which has been generated elsewhere outside the country. So for example, I've just presented my device in UK. There's a huge interest there. South Africa, US would be able to roll it out to these other countries where obviously rugby injuries and other low velocity injuries are quite common. It has been a challenging process, but I must say the Canterbury can-do attitude has certainly helped this process. It has taken us 4.5 years to get where we are, but this wouldn't have been possible without the help and supervision which I have received from my colleagues, as well as the nursing staff in Ward 19 intensive care unit. What I would like to say to anybody who is keen on innovation, I would suggest that you first get your patent sorted out. You make sure that you've got a strong patent, and what follows from there is all available here in CDHB. So Innovation Hub would be the way to go forward. They have the right skill mix to be able to progress your product or your ideas, and I think that help is invaluable.